So it's Movember. You know what that means. Sponsor me! Information's in the description below. Early this morning at dawn, tens of thousands of people flocked to the beaches across northern Australia to witness the first solar eclipse the country has seen in over 10 years. Unfortunately, when they got there, they may have found that the forecasted bad weather had obscured their view of this natural phenomenon. But, as meteorologists promised, there were at least some breaks in the clouds. A solar eclipse, which is what happened in Australia this morning, is where the moon gets in the Earth's way of the sun and casts a shadow big enough to block out all the light. The shadow, measuring about 95 miles across, swept across the northern coastline of Oz, and even a partial eclipse was seen from Indonesia, New Zealand, Papua New Guinea, Chile and Argentina. There's also another kind of eclipse called a lunar eclipse, when the Earth gets in the way of the moon and the sun and casts the Earth's shadow on the moon. The solar eclipse casted Australia into darkness for around 2 minutes. Scientists in the area took this opportunity to study the effects of unexpected and sudden darkness on the sea life around the Great Barrier Reef that is ever receding, as explained in this previous video. So if you're a keen Australian astronomer and you were lucky enough to get down to see the eclipse, please let us know in the comments below. Speaking of celestial bodies, I want to tell you about something interesting that caught my eye about the moon this week. Ever stepped out and thought to yourself, hell, that moon looks big tonight? I'm sure we've all done it, but what is it that causes this difference in size? Does the moon get closer to the Earth? Or is there some sort of atmospheric lensing going on? No, not at all. It's actually just your brain tricking you into thinking the moon is bigger than before. When the moon's closer to the horizon, your brain has a reference point to compare the size of the moon with the objects on the skyline, which in turn confuse your brain and make it seem like it's really big compared to those objects. However, when the moon's high up in the sky next to the tiny dots that are stars, it seems really small and lonely. Similar to something called the Ebbinghaus illusion. Take a look at these two orange dots. Which one seems bigger? In fact, they're both the same size. It's the size of the surrounding dots that confuses your brain and makes one seem bigger than the other. Another effect that may be throwing you off is your brain's preemptive way of discerning objects that pass nearer to the horizon. When, say, a cloud or an aeroplane moves away from you, it gets nearer to the horizon and gets smaller as it gets further away. Now, the moon doesn't follow this trend. It stays the same size no matter how close to the horizon it is. But because your brain is used to objects getting smaller as they approach the horizon, it overcompensates for the size. So there you have it. The moon never gets any bigger or smaller. It's just your mind playing tricks on you. Don't believe me? Compare its size with your thumbnail next time you're out on a clear night, or even take a few pictures at the same zoom level. You'll be surprised at the results. Seeing we've not heard from him in the past few weeks, I think it's about time we caught up with our Martian friend up there, the Mars Curiosity Rover. So after a few weeks of playing around with Martian time, the team have finally switched over to Earth's timekeeping methods for the planning of the rover's movements. As the Martian days are 40 minutes longer than ours, the shift in time over the last 3 months meant that the team would now be working nights, if they hadn't returned to Earth time for the planning shifts, and it's reported the changes made them more efficient. There's still been no material dispensed into the SAM unit for analysis, so what have they been doing? Taking MySpace style arms length pictures of themselves, that's what they've been doing. Not only has it been blogging its pic to all its followers on Twitter, but it's also been sniffing the Martian atmosphere to determine its composition. It's found that what's left of the atmosphere on Mars is made up from at least 95% CO2, the other 5% comprising of argon, nitrogen and carbon monoxide. So it's not exactly something you want to be breathing. The SAM, or Sample Analysis Mars unit that I keep rambling on about, is made up of a few different arrays of instruments, all designed to analyse materials from the surface, and in the atmosphere for that matter. First we've got the mass spectrometer and the gas chromatograph, which are both used to vaporise and analyse material from the environment to work out its composition. There's also a laser spectrometer to do a similar thing, but instead of vaporising the material, it bounces light off it. The SAM unit also contains 2 ovens, capable of heating material up to thousands of degrees. Later this week they're supposed to be getting to use it with some samples, so we'll let you know how they got on with that in next week's show, if they manage to get around to it, that is. For the latest on Mars Curiosity, you can nip over to NASA website as usual, or catch up every week in our weekly news shows. Before I go, I've got a spot of Deej based news for you. I'm doing Movember, in case you haven't noticed, and so are several others, so why not sponsor our team? There's a link in the description below to our Movember page, or if you prefer, you can text your donation through Just Giving by sending a message containing the code MOVE58, a £, and your amount to 70070. Special thanks to anyone who sponsors us, as it is all for a good cause. Don't forget to follow us on Facebook, Twitter and Google Plus for the latest from us, and as always, thanks for watching. I'll see you next week.